Okay, now let's start the first part, the introduction of our MHT 25 to 50 kilowatt inverter. So the MHT 25 to 50 kilowatt inverter is our three-phase hybrid inverter, which has been designed specifically for the CNI projects, and it offers multiple power options from 25 kilowatt, 30 kilowatt, 36 kilowatt, 40 kilowatt, and 50 kilowatt, so that we can offer our customers a great flexibility to meet the different requirements of different projects. And if we have connect the battery and the meter inside the system, we can support the 24-hour load monitoring and the intelligent power export limitation, so that we can ensure that the energy is safe for critical loads, which is especially important for the CNI projects. And also, our inverter can help to maximize the PV power access, the green power use, and also help to minimize the grid generation. So in short, this inverter is designed to operate in a more stable, more smooth, more safe, and a more convenient way, and offer our customer a reliable choice under different conditions. So for this part, let's see why this inverter is so suitable for the CNI application. And we can see from the diagram over here, so this shows a parallel system. So each inverter over here have connected with the PV panels, the battery, and the critical loads. And thanks to the master slave control, so now the whole system can under the monitoring of our Solinteg cloud. And also, so for this inverter, we can support up to 10 units of on-grid parallel connection, and we can support 4 units of off-grid parallel connection. That is to say, the power range of the whole system could be ranging from 25 kilowatt to 500 kilowatt. And if we're using the vehicle battery as an example, the maximum capacity could be reached to 1.71 megawatt hours. So that is to say, this power range and this capacity range says that our system could be a very suitable choice for both residential and especially for the CNI applications. And here is the naming rule. So from the model name that we can see, the first letter, the M, means that it refers to our product series name called the Power Master. And the H here refers to that this inverter is a hybrid inverter. And the T means that it's a three-phase inverter. And the number over here, 40K, refers to the rated output power of this inverter. And the number over here, the 100, means that the maximum charging and discharging current of this inverter. And the letter P here, well, it actually refers to that the different version of this inverter. Well, we have the normal version and we have a plus version, but we don't. The plus version is not a very common choice, so we're mainly using the normal version. Okay, so here shows the typical application scenarios of this inverter. Well, this inverter can covering the application scenarios like the villas, the factories, the malls, the industry parks, and the schools. So next we'll come into the most important part of the introduction today is about the key features of this inverter. Well, let's see from this slide that we have divided these features into 6 aspects. And let's first look into what features that make our inverter such a powerful choice. Well, first, let's take a look at the 150% of the PV oversizing. And we can use this slide for a better understanding. As we can see, so when the sunlight is very ideal, in this case, we can, for example, we can use 100% of the power from the PV to support the home load, and we can use 50% of the power from the PV to charge the battery. So as we can see from this picture, so now all the power coming from the PV panels is 75 kilowatt. So in this case, we can send 50 kilowatt power to support the load, and we can send 25 kilowatt power to charge the battery. So with this function, we can achieve the higher capacity for loads and the battery, and also help to maximize the use of green energy. Okay, now let's go back. So the next point of the powerful features is that we can support from 15 ampere to 16 ampere in the MPPT input current. And to give us a better understanding, we can combine it with another feature over here, is that we have multiple MPPT choices and we have 8 PV strings in total. So let's first see this feature. Okay, so we can first take a look at the picture on the right side, that this is a very typical industrial roof. It have different orientations, and the user have installed the PV panels in these different roofs. So we can just imagine that if the user is now using the inverter that doesn't offer us some multiple MPPT choices. So in this case, the user whether need to give up to install the PV panels in one or two orientations, or the user would just need to accept the fact that the total efficiency of the system will not be that high. But with our inverter, which offers you the multiple MPPT choices, with the Plus version, it gives you 2 MPPT with 8 PV input ports, and with the normal version, it gives us 4 MPPT, and it has 2 PV inputs per MPPT. So in this case, like the picture shows, we can connect each MPPT with a string installed in different orientations, and all this MPPT can be combined in our inverter. So in this case, that is to say, if we are using our inverter in such a scenario, we can connect with the PV strings from different orientations, and we can connect the different PV strings from different brands. So, and for example, over here, so there is some shadow from this orientation, but for others, there is no such shadow. So if we are using the multiple MPPT choice, that means that so the shadow over here won't affect another PV strings connected with other MPPT. So in this case, we can help to optimize the PV access. And also, so with the multiple MPPT choice, we can offer our user more power generation by it. And thanks to the wide MPPT voltage that our inverter can offer, so we can offer the max power point to be tracked with our inverter. So, it can enable the inverter to be flexibly to connect with the PV panels. And from here, we can see that our MHT 25 to 50 kilowatt inverter, they are designed with strong PV input capability, which makes them compatible with most mainstream PV panels available in the market today. So whether it's different technology like PERC, TOPCon, HJT, or others, or the PV model ranging from 450 watts to 670 watt, our inverter can support them all. And with a flexible input current option, for example, the 15 ampere, the 20 ampere, and the 13 ampere, the system can easily adapt to the mainstream PV models at the present, or some new generation PV models with with much more power and higher current PV models in the future. So next, let's see how to set these different PV input solutions. So if all the PV strings we want to connect, they have less than 15 ampere input current. So in this case, we can just use each PV string to connect with different PV inputs on the bottom of our inverter. We can just connect the PV string with the PV input port over here. So in this case, the maximum PV input current our inverter can accept is 15 ampere. And what if we want to use some high power PV strings, like when the current have reached, for example, 17 ampere. So in this case, we can choose to use the Plus version of this inverter, which has 2 MPPT and has 4 PV inputs in 1 MPPT. So in this case, we can just use 3 PV inputs. And at this case, so each PV input can accept the current of 20 of 20 ampere. So that is why we can connect with some higher current PV panels. And if we want to connect with some even higher current PV panels, we can use this solution. That is to say, using the normal version of our inverter with 4 MPBT, and we can just using one PV input per MPBT to connect with our PV strings. So in this case, the maximum PV input current is 13 ampere. So that is why we can offer our users the different solutions according to the different requirements of their project. Okay, so now let's go back. So another feature that makes our inverter a powerful choice is that we can support the 110% of continuous AC output. And we can use a simple example to explain that. For example, when we are using a 10 kilowatt inverter, and if the inverter supports a 110% of continuous AC output, so that means during some peak generation hours, the maximum output power could be reached to 11 kilowatt, and that can give us the extra headroom during these hours. And what's more, we can expand our inverter up to 10 units in parallel under the on-grid situation. So the next part is about high efficiency. Well, first, our inverter can support up to 98.8% of maximum efficiency, and that means you can get more power from the PV side. And here we can also support the 100% of unbalanced output. And we can see the slide over here. So first, we can compare two situations that if the inverter cannot support the unbalanced output, or using our inverters that support this function. Well, first, let's take a look at this diagram over here. So if some inverters they cannot support the function of unbalanced output, that means you would need to give the equal power through each phase. For example, over here, now we have installed the different devices in different phase, and each device requires different power. But as the inverters, it doesn't support this unbalanced output function, so it will just give the same power to each phase. And let's see what will happen. Well, for example, let's first take a look at the phase over here. So now the device installed in this phase, it required 5 kilowatt power, but the inverter still sends a 10 kilowatt power. So in this case, your 5 kilowatt power that has been wasted, it will be sent to the grid if there is no power export limit. And so if we are in some countries that we can send the extra power to the grid and even get some credits, the energy bill will not be that bad. But if we are in some countries that have the power export limit, or we can't get credits when we are sending the extra power to the grid, that means this 5 kilowatt power will just be wasted. And let's see the next one. So for the device installed in this phase, it requires 10 kilowatt and the inverter gives a 10 kilowatt. So this is perfect. But if we take a look at this one, so the device installed in this phase, it requires a 15 kilowatt power, but the inverter can only give this device 10 kilowatt power. So in this case, we will still need to buy 5 kilowatt power from the grid, which will increase our electricity bills. So let's see what will happen if our inverter can support the unbalanced output. So in this case, we can send the independent output in each phase. For example, we can look into the diagram of here. So now the device needs 5 kilowatt power, and we can just send 5 kilowatt power to it. And for the device who needs the 15 kilowatt power, and we can send the required power directly to this device, so that we can help to optimize the load power supply without increase our electricity bills or without wasting any generated energy. And in this case, we can maximize the system's energy utilization by having this 100% unbalanced output. Okay, so another point that can increase the efficiency of the whole system is about the shadow scan. And we can look into the slides over here. So the ideal condition is that there is no shadow on the PV panels. And in this case, the power generation curve will be like this, follow the blue line. And there is only one max power point in this curve. And the inverter will just follow this max power point to work and generate the power. But what if that we have some shadows on the PV panels? And in this case, the power generation curve will be like this. So it will have many max power point. And for some inverters, they don't support the shadow scan function. And that means this inverter might find the low max power point and then start to work at this point. And that means it will lose part of the PV generation. And for our inverter, which supports the shadow scan function, it will keep looking until it finds the highest max power point. So the inverter will start to working at that point, and we can make sure that the efficiency of the total system has been increased, and also we can optimize the system's power generation. So the next part is about the strong backup, which is very important during our daily operation. So first, our inverter supports a less than 20 milliseconds of seamless auto switching. And this means that when the grid goes down, and our inverter can switch to the backup power in less than 20 milliseconds. Well, for most loads, like the lights or like the computer, the switch is so fast that the users will not notice that, well, there is a power interruption and the light, they stays on and the computer won't restart. And the operation in your house will continue without disruption. And the next part is about our ability of supporting the 100 ampere charging and discharging current. And we can take a look from here. So for this inverter, we support with one battery port, and it provides up to 100 ampere of charging and discharging current. So the first thing is that we can charge the battery and discharge battery in a really quick speed so that we can support more power to the whole system and also increase the total efficiency of the total system. And what's more, if we compare it with some other inverter brands in the market, they have two battery port, but each battery port can only provide 15 ampere of the charging and discharging current. And what if that we want to connect the system with the same capacity of the batteries? For example, if we want to connect a 100 kilowatt battery inside the system, and if we're using this inverter, and that means we only need to connect with one battery stack. And if we using other inverters in this market with two battery port and each battery port supports the 15 ampere of charging and discharging current, and that means we might need to split up these batteries into two groups, and each stack is 50 kilowatt of battery. And for users, this is actually not a very ideal choice because the user will need to pay more for this extra BMS and the extra base. And for the installers, they will need to spend more time to install the system like this. So in short, the benefits of the 100 ampere charging and discharging current is very clear that we can bring the higher density of the connected battery and we can also help the customers to spend less with just only one BMS and the base. And also, we can save the time for our installers in the battery installation process. So the next part is that we can support the diesel generator. Well, in many areas that might encounter with frequent power outages, so this solution is very important. And now, as we can see from the diagram, we can connect the diesel generator with our inverter through the GEN port. So at this case, the diesel generator, they can provide another key method to support the whole system. And also we can control the diesel generation by many intelligent and options. For example, we can start the diesel generator according to the SOC of the battery, or we can start the diesel generator depending on whether the grid is still there. And also, the AC power generated by the diesel generator can not only use them to support the home load, and we can also use them to convert into the DC power and then charge the battery. For now, our inverter can compatible with most diesel generators in the market. And the next is about our settings of 6 that we offer 6 time of use settings. And the time of use over here means that we can set the different charging schedules according to different time slot. And now we can offer 6 time slot for our users to choose. So this function is especially useful if some customers they want the system follow his habits, or it is very useful during some areas that have the peak and valley electricity prices. So now let's move to the next part about the smart energy management. Well, first, now we can add some smart loads into our system. For example, over here. So the smart loads over here mainly refers to the heat pump. So so in our system, we can connect with some heat pump that has the SG ready, so that we can make the effective use of all the green energy, and also we can increase the comfort in our daily life. And there are many ways for us to control the smart device like heat pump through our app. For example, we can running the heat pump with the excess of our PV power. Well, for example, in some normal cases, when we have already used the PV power to support our home load, and we have already used it to charge the battery. And for some extra power, we can use it to running our heat pump, or we can running our heat pump with the battery's power. For example, we can set the different SOC. We'll take this as an example. For example, we set that when the SOC of the battery have reached 80%, and right now we can use this power from the battery to start the heat pump. And we can also set an end SOC. For example, when the SOC of the battery have now reached the 15%, so now we can stop using the power from the battery to charging the heat pump. And we can also using the heat pump based on our living habit, or we can start to running the heat pump whenever we want it remotely. Okay, so the next part of the smart energy management is about that we can offer 5 preset working modes through our integrated EMS. And besides, now we can also offer the smart power export limitation, which is a new function that we have just upgraded. Well, this function is mainly for some areas that might have the negative electricity price. And the principle is that when the system have detected that there is negative electricity price outside, and it will just stop the power export immediately, so that we can prevent our customers from being fined by the utility company. And the next part is that we now can support the IoT connection in our system. Well, we now have worked in conjunction with some third-party energy management platforms like Solar Manager, like Enjoy Lag, like CheckWatt, so that we can link every smart devices inside our house and finalize the intelligent control. So in this way, we can add the green energy inside our house and live a more comfortable life through this IoT connection. So the next part is about the user-friendly side of this inverter, and we can take this as an example. Well, the first part is the highlight in the center of inverter. Well, this is the innovative and aesthetic design of our inverter that we can see that it has different colors and it will flash differently so that our users they can just see the working status of this inverter directly by these signs. And over here, there is an OLED display. So from this display, we can see some simple informations of this whole system. And also we can use this button over here along with the display to finalize some simple configuration. And also we can notice that comparing with some carbonate inverter like over here, so our inverter has a super lightweight, and this have many benefits. For example, it will definitely bring the convenience during the transportation, the storage, and the installation. And also, it has less requirement of the installation space comparing with the inverter like this. And so our inverter can help to reduce the wiring errors during the installation so that it can help the installers to save much time when they're installing the projects with the same capacity or the power range. So the next part is about our full security protection of this inverter. So as we can see from this slide that our inverter can support a seamless auto switching with less than 20 milliseconds of on-grid or off-grid switch. And also we can support a Type 2 SPD, which is the surge protection device in both the DC side and the AC side, so that we can prevent our inverter from the damage of some lightning or the surges from the grid. And besides that, we can also connect an external emergency stop with the inverter, so that in case of some emergency, we can just click this button and the inverter will shut down the AC side immediately. All of these designs, along with our integrated protection level, which is IP65. So this can ensure that the users we can install this inverter inside or outside this house. So all of this design can give us a worry-free experience during the power outages, the bad weather, and the emergencies. So that is the whole part of the key features. And next, let's enter into the compatible batteries part. And as we can see from here, so our MHT 25 to 50 kilowatt hybrid inverter now can compatible with many leading battery brands, including Solinteg, Dynas, Vico, Soluna, and some other brands. And if you want to know the latest brands that we can connect with our inverter, you can contact with our technical support team, or you can go to our official website to download the latest list of the compatible batteries. And as we have mentioned, if we using the Waco battery as an example, the maximum capacity could be reached to 1.71 megawatt hour. So all of this making this inverter such a suitable choice for versatile situations, including the residential scenarios and the commercial scenarios. And we can look from here to see the combination of our inverter and some other battery brands. For example, first, let's take the Solinteg battery as an example. Well, the capacity range of the Solinteg of this the capacity range of the system while we're using the Solinteg battery can be ranging from 7.1 to 579.6 kilowatt hour. And if we are using the battery from Dynas, so the capacity range could be from 7.1 kilowatt hour to almost 800 kilowatt hour. And if we are using the batteries from Vico, so at this stage, the maximum capacity could be reached to 1.71 megawatt hour. And if we are using the battery from Soluna, and in this case, the maximum capacity could be reached to 150 kilowatt hour. And if we are using the batteries from Lithium Valley, and in this case, the maximum capacity could be reached to 344 kilowatt hour. I'm sorry. And if we are using the batteries from Sangwangda, so in this case, the maximum capacity range could be reached up to almost 200 kilowatt hour. So now let's see the different system solutions with our inverter. Well, we can see from this diagram. So this diagram shows the typical system, which is the on-grid system. So now the inverter have connected with the PV strings, the battery, and the backup loads, and the on-grid loads, and also connect with the smart meter CT, and finally connect with the grid. So in this case, the principle is very simple. So the PV will generate the power, and the inverter will using this power to support the load, and also using this power to charge the battery. And if we have some extra power, we'll use them to send to the grid. And during the nighttime, when the PV doesn't generate the power, we can choose to using the power from the battery to support the load. And also, if we need it, we can send this extra power to the grid. And here is a purely off-grid system. And in this case, we only connect our inverter with the PV strings, the battery, and the backup loads. And at the daytime, the PV will generate the power, and the inverter will using this power to support the backup loads and also charge the battery. And at the nighttime, the inverter will using the power from the battery to support the backup loads. And this is a AC coupling system. So this is mainly used for some families that they might have already installed the on-grid inverter inside their house, but right now they want to add a battery inside their system, or they want to make sure that the backup loads can be supported safely inside the system. So in this case, we can connect the hybrid inverter with the on-grid inverter on the AC side in this system, and we can connect the battery and the backup loads with this hybrid inverter. And in this case, so we have finalized the AC coupling system, but we need to be noted that during this system, we need to make sure that the brand of the on-grid inverter and the hybrid inverter should be the same. So that we can finalize the function of power export limitation. And if you are using another brand's on-grid inverter, as long as this brand can give us their protocol of this inverter, so that we can control the output of this on-grid inverter through our data logger, so the system can still working. And here is the generator system. So as we have mentioned before, now we can just skip this part. So this is also what we have mentioned before, the parallel system of the whole system. And let's do a quick refresh so that our inverter can support up to 10 units of on-grid situation in parallel, and we can support up to 4 units on the off-grid situation in parallel. So that is to say, our power range of the whole system could be expanded from 25 kilowatt to 500 kilowatt. And if we're using the vehicle battery as an example, the maximum capacity range could be reached up to 1.71 megawatt hour. So now let's see the different working modes that our system can support. The first one is the general mode, and this is the most common one during the daily operation. And the principle is very easy, that the PV will generate the power, and the PV will generate power to support the home load, and also using the extra power to charge the battery. And if there is some extra power, we can use it to send to the grid and to get some credits. Or during the nighttime, when the PV is not enough to support the home load, we can using the power from the battery to support the home load instead. And here, let's see the peak load shifting mode. So for this mode, we can see, so this mode is especially designed for some places that have set the limitation of the power we can take from the grid, and we can set that value as Pmax for a better understanding. So we can divide this working mode into 2 conditions. The first, when the power required from the load is now lower or equal than the Pmax. So at this stage, the PV and the grid will support the home load together and also use them to charge the battery. And during this stage, the battery won't discharge. And only when the power required from the load is now higher than the Pmax, and in this stage, the battery will discharge and fill in this gap. And so filling this gap, as we can see from the diagram over here. So at the evening or at the very early morning, so when the power required from the load is not very high, so at this stage, the grid will power the load. And when everyone is wake up, so now this time the power required from the load will be higher than the Pmax. And so at this stage, we can see that the battery start to discharging now, and it will use this power to support this home load, the requirement from the home load. And during the daytime, the PV will start to generate the power so that it can support the home load and also use this power to charge the battery. And for some extra power, they will be feeding to the grid. And during the late afternoon, when the power from the PV will not be able to support this home load. So in this case, we're still using the power from the battery. We can notice that in this stage, the battery is now discharging right now, so that the battery will power the loads. And during the nighttime, when the power requirement from the load is not very high, at this stage, we're still using the power from the grid to support the load and also use this power to charge the battery so that we can help our users away from having to pay the extra bills for those extended power. And next, let's see the economic mode in our system. So the economic mode is mainly for our first generation of the inverter. And in the second generation of our inverter, we have upgraded into the TOU mode. But the principle is the same. So this economic mode is especially used in some places where we have the peak and valley electricity price. So in this case, we can set the different charging and discharging status according to the different time. For example, when the electricity price is very low right now, we can using this time to running at the charging mode to charge our battery. And during some times when the electricity price is quite high, we can use the power from the battery to support the home load, or we can even use this power to feed into the grid and get some credits. And the next one is the UPS mode. Well, for this working mode, we can divide it into two conditions. The first one, when the grid is still there. Well, in this case, it's similar with the general mode that the grid and the PV will support the home load together and also charging the battery. And under the UPS mode, when there is grid inside this system, the battery won't discharge. And until the grid is failed in this system, the battery will start to discharging, and the system will using the power from the battery to support the load. As we can see from the diagram over here, for example, when the grid is still inside this system, and at the nighttime, the grid will power the loads, and at the daytime, the PV and the grid will support the load together, but they will first make sure that the battery is fully charged. And after that, when at the nighttime, when the PV doesn't generate the power, the grid will support the load. And we can see from here, so if the grid have failed, during the nighttime, the battery will power the load, and during the daytime, the PV will generate power to support the load and also charge the battery. In the nighttime, still, the battery will power the load. And we need to be noticed that actually our system is designed for some typical household demands without experiencing the power outages. So we don't recommend that we're using this system to support some life-saving devices, like some medical equipments. It cannot guarantee uninterrupted backup in these extreme situations. So that should be noticed during the system designing process. And the next part is about the off-grid mode. So on the purely off-grid mode, we can see from the diagram. So at the daytime, the PV will generate the power to support the load and also using this power to charge the battery. And during the nighttime, we're using the power from the battery to support the load. So that is all the parts for the introduction of our MHT 25 to 50 kilowatt inverter.